So this is Dr. A. Weissman Lenz, Assistant Professor of EEE, Wales Institute of Science, Technology and Advanced Studies. So in this video, I am going to explain about the multi-quadrant operation of the hoist load. So we know that motor is driving a load is basically a drive. So the motor drives the load, which may be a translational motion or it may be a rotational motion. So the angular speed of the motor, it is given by a notation called omega m, that is nothing but the instantaneous angular velocity of the motor shaft, which is given by the unit radian per second. And the motor developed torque is given by the notation called T, that is the unit is given in Newton meter, and TL is nothing but the instantaneous value of the load torque, which is referred to the motor shaft, and the unit is given by Newton meter. So J is nothing but the polar moment of inertia of the motor load system. So depend upon the value of the T and the TL produced, the motor acceleration or deceleration is decided. So when the motor torque is greater than the load torque, which means that the motor is accelerating. So the motor should develop a torque more than the load torque. So as we know that the basic torque equation, T is equal to TL plus J into d omega m by dt. So the motor should develop a torque which is equal to the load torque plus it should be able to counteract the dynamic torque also. So J into d omega m by dt is nothing but the dynamic torque. And for the drives with constant inertia, T minus TL is equal to J into d omega m by dt plus omega m into dj by dt. So when the differentiation of dj by dt is equal to 0 for drives with constant inertia. So for the drives with variable inertia, T minus TL is equal to J into d omega m by dt. So this dynamic torque comes into account only when the drive is in transient operation such as starting, stopping or acceleration or deceleration. So the drive accelerates when the motor torque is able to produce the load torque plus the dynamic torque. The motor decelerates when the motor torque is less than the load torque. And the direction of the motor torque and load torque are always opposite. So as we can see in the diagram, the motor torque and the load torque is always in opposite direction. So we are going to study the 4-quadrant operation of the drive by using the load hoist as an example here. So basically there are 4 quadrants of operation. So every drive it is capable of producing 4 quadrants, but some drives it operates in 1 quadrant, or some drive it operates in 2 quadrants, and some drive it is capable of operating in 4 quadrants. So if it is a single quadrant, then it finds its application in compressor and pump. For automobile generally drives in 2 quadrants, that is the first quadrant and the third quadrant. And in operation such as hoist load or for the movement of the hoist in upward and downward motion, we go for the 4-quadrant operation. So the 4 quadrants of operation are forward motoring, forward braking, reverse motoring and reverse braking. So here when the drive is involving in upward movement, the direction of the motor is considered to be a positive, which means that the motor rotates in counterclockwise direction. So at that time, so we know that P is equal to T into omega m, the basic formula for power. So when the motor speed is positive and the developed motor power, that is T, is also positive, then the developed power is positive here. So so this is explained by using the speed torque characteristic curve. So here in the first quadrant, the direction of the positive speed is arbitrarily chosen. So the direction of the positive torque will produce the positive speed. So as we can see here, in the first quadrant, the drive operates in counterclockwise direction. So the direction of the speed, it is given by the counterclockwise direction, and the direction of the electromagnetic torque is also given in the counterclockwise direction. Since both the sign of the speed and the electromagnetic torque is positive, the power developed is also positive here. So the quadrant 1 is forward motoring, and the quadrant 2, that is the forward braking, again the drives involve in upward movement. So the motor the speed of the motor is positive, and the electromagnetic torque is negative here. So what happens here? The P is equal to T into omega m. So, though the power is positive, since the power developed by the motor is negative here, the developed power is negative. So that is nothing but braking operation. And in the third quadrant, that is nothing but the reverse motoring. The drive involves in downward movement of the loaded cartridge. So what happens? The downloaded cartridge, it produces the speed in clockwise direction. So the direction of the speed is considered to be negative here. For downward movement, the speed of the direction is considered to be negative, and the electromagnetic torque is also developed in the same direction. So since both the speed and the electromagnetic torque are in the same direction, the developed power is positive here. And then the fourth quadrant, the developed power is negative here, because the direction of the loaded cartridge is going to be downward, so the direction of the speed is negative. So when the drive involves in downward movement, the speed of the motion is considered to be negative, and the developed torque is positive here. So what happens here? P is equal to T into omega m. So positive into negative, so the developed power is negative. So these are the four quadrants of operation, and here we are going to explain it by analyzing the hoist load. So in the hoist load, a brake drum is connected to the motor shaft, and a rope is mounted on the brake drum. It is like a pulley. So on one end of the rope, a counterweight is attached. On the other end of the rope, a loaded cartridge is attached. Basically a loaded cartridge. Sometimes it might be a empty cartridge also. So the hint here is that the counterweight, it should be greater than the empty cartridge, and it should be lesser than the loaded cartridge. Here TL1 and TL2. So TL1 is nothing but the difference of torque due to the counterweight and the loaded hoist, and TL2 is nothing but the difference of torque between the counterweight and an empty cartridge. So TL1 it comes in quadrant 1 and 4, and TL2 it comes in quadrant 2 and 3, because first quadrant and the fourth quadrant it has a loaded cartridge, and the second quadrant and the third quadrant it involves with an empty cartridge. So when we see the operation of the first quadrant, so here we can see that in the first quadrant the motion is upward, in the second quadrant also the motion is upward, in the third and fourth quadrant the motion is downward. So this is the first quadrant. So as we can see in the picture here, the motion is to be upward here. So the loaded cartridge has to be pulled upward. So as I have already told you the hint, the counterweight, it should be lesser than the loaded cartridge. So in order to pull the loaded cartridge upward, the torque has to be applied in counterclockwise direction. Only then the loaded cartridge can be pulled upward. So when the loaded cartridge is pulled upward, definitely the direction of the pulley is going to be rotated in counterclockwise direction. So the direction of the speed is given in a counterclockwise direction, and the torque which is applied is also in anti-clockwise direction. So the anti-clockwise direction, we have drawn the direction of the electromagnetic torque, or the torque developed by the motor. So as I already told you that the load torque is always opposite to the motor torque. So the direction of the load torque is always opposite to the motor torque here. So here, since the speed of the direction of the motor and the developed torque is in the counterclockwise direction, the developed power is positive here. So the torque and the speed of the motor are in the same direction, and the load torque is opposing the motor torque. So in the first quadrant, it is going to operate as a motor, which means that the power is going to flow from the machine to the load, and it operates as a motor. So the same machine can be made to work as a generator or a motor. So it acts as a motor when the power flows from the machine to the load. It acts as a generator when the power flows from the load to the machine. So the first quadrant is acting as a motor. So this is the second quadrant, that is the forward braking. So in the second quadrant, the empty cartridge has to be moved upward. So the hint says that the counterweight is lesser than the empty cartridge. So due to the gravitational force, there are chances for the counterweight to go and hit the ground very forcefully. So at that time, the empty cartridge also go up and hit at the top. So we have to apply a braking torque in order to pull the empty gauge in a safer limited speed. So so when the empty gauge is pulled upward, definitely the direction of the motor is going to be in counterclockwise direction, but we need to apply a braking torque in order to pull the empty gauge upward in a safer speed. So the direction of the speed and the developed motor torque are in opposite direction here, and as I told you, the load torque is always opposite to the motor torque. So in this operation, what happens here is it acts as a generator. So generator in the sense the power is returning back to its source. This operation, this usually happens in the case of the regenerative braking. So the speed of the direction, it is unchanged, while the direction of the torque alone is reversed here. And this is the third quadrant, that is the reverse motoring. So reverse motoring in the sense, as we can see the picture here, the motion has to be downward. So the empty gauge has to be pushed down. The empty gauge has to be pushed down. So which means that the empty gauge, the weight of the empty gauge is lesser than the counterweight. So this empty gauge has to be pushed down. So when the empty gauge is lowered, definitely the direction of the speed is also going to be in the downward direction. So downward direction in the sense the speed is considered to be negative here, and the brake is, since we have to push the empty gauge downwards, the torque has to be applied in the clockwise direction. Only then we can push the empty gauge downwards. So at this time, the direction of the speed of the motor and the developed torque is going to be in the same direction. So what happens? The developed power is positive here. So it is going to act as a motor. Motor in the sense the power always flows from the machine to the load, and at this time the machine acts as a motor here. So it is just like a first quadrant, but the direction alone is different. So since the torque and speed of the machine are in the same direction, the power flow from the machine to the load, and it acts as a motor rotating in reverse direction, just like the first quadrant, but the direction alone is reversed. And the fourth quadrant, it is a reverse braking. So here in the reverse braking, the loaded gauge has to be pulled downward. So we know the hint that counterweight is always lesser than the loaded gauge. So the loaded gauge has to be pushed downwards. So what happens here, since the weight of the loaded gauge is greater than the counterweight, due to the gravity, the loaded gauge may go and hit the floor accidentally. So in order to avoid that, we have to push the loaded gauge downwards in a very safer speed and very slowly. So for that we need to apply a braking torque in counterclockwise direction. Only then the loaded gauge can be pushed downwards in a very safer manner with a limiter safe speed. So here, since the loaded gauge is moving downward, the speed of the direction has to be downward, and when the speed of the direction is downward, it is considered to be a negative sign. And here we can see that the developed motor torque, that is braking torque, we have to apply a braking torque in order to lower the loaded gauge in a safer limit speed. So the direction of the speed and the torque are in opposite direction, and so when the developed power is negative, it is going to act as a generator. So generator in the sense, it is going to be in a regenerative mode, that is the power flows from the load to the machine here. So the developed power is negative here, and as we know that the load torque is always opposite to the motor torque here. So the first and fourth quadrant of operation can be explained with the help of the elevator. So whenever the elevator is going upward or downward, the direction of the load torque remains unchanged, but the direction of the speed alone is reversed. So as we know that the forward motoring, so when we see the forward motoring, it is the first quadrant, and the speed developed is positive, the torque developed is also positive. So the power developed, P is equal to T into omega m. So speed into torque is nothing but power. So mechanically when we see, so the speed into torque is positive power. In the forward braking, that is the second quadrant. So in the second quadrant, the speed is positive, the torque is negative. So the power output is going to be a negative one. In the reverse motoring, that is the third quadrant, the speed, the direction of the speed is negative and the direction of the speed torque is also negative. So negative into negative, positive. So the power developed is positive in the third quadrant. In the fourth quadrant, that is the reverse braking. So the speed is speed of the direction is negative because it is involving in downward movement. The speed is considered to be a negative here, and since the braking torque is applied in anti-clockwise direction, the torque direction is positive. So positive into negative, so negative, so the developed power is negative here. So it finds its application in compressor, pump and fan type load. So these type of loads, it operates in only one quadrant, which means that their operation will be in unidirectional function only. So they are all called one quadrant drive system. And transportation drive, they require operation in both directions. So as we all know that regenerative braking, so when the car is moving downward, so the kinetic energy which is stored in the motor, it is going to be supplied back into the source. So so they are restricted to the quadrants 1 and 3, and at times when we need dynamic braking or mechanical braking may also be employed. And in the hoist drives, the 4 quadrant operation is needed. So which is which makes the drive to operate in all the 4 quadrants, that is the forward motoring, forward braking, reverse motoring and reverse braking. So thank you. Hope you all have got some idea about the 4 quadrant operation of the multi quadrant drive.